Hello, my name is Carrol Estevao Lay, and today I'm gonna explain about my video from the section C. Uh, and my ID is 103012450002. First, I'm gonna read the question. So here, Bill takes 300 milligram blood pressure tablet every morning. At the same time, the drug decay exponentially in the bloodstream at the constant hour. Rate K equal 0.12. So in A, we gonna how many of milligram of the drug remain in the body 24 hours later, just before the second dose? How much just before the third dose? So from here, we're gonna count it. So we're gonna define A0 is 300 and K is 0.12 and T is time since the dose in hours. So from the hint, we know that A is equal to A0 times exponential minus k times t. So from here we're gonna see that a is equal to 300 times e exponential, oh, 300 times exponential the power of 0, my 0 the minus 0 times 12 times 24, because it's 24 hours the first we count, and the value is gonna end up like 600 or 16.83 milligrams, and the 48 hours is the first dose is we're gonna declare it as A1, and A1 is 300 times e times e the power of 0 minus 0 comma 12 times 48, because it's 48 hours, and the result is gonna end up at 0.942 milligrams. And second dose, we're gonna define it as A2. A2 is equal to 300 times exponential minus the power of minus 2 comma 88, and the value is end up A2 is 16.83 milligrams. After this, we're gonna total them all. So A total is equal to A1 plus A2, and we're gonna get 17.77 milligrams. Now we go into section B. Section B is the long run, how much the drug remains in the body before each new dose. Okay, uh, from here we're gonna use the geometric series. So the first dose, for the first dose, we're gonna declare it as 24 hours minus 300 times exponential minus 2.88, and the second dose is gonna be 300 times exponential the power of minus 2 times 2, oh, the power of minus 2.88. So here we know that the S value, the series is equal to 300 times exponential the power of 2.88 plus 300 times exponential minus 2 point minus 2 point the power of minus 2.88, and until continuously. So here we know that the A is equal to 300 times exponential the power of minus 2.88, and the ratio is exponential the power of minus 2.88. So here we're gonna sum all of them, and the formula for sum is A over 1 minus R. And from here we have this calculation, and the value of the calculation is gonna end up to be 17.83 milligrams. So in conclusion, before the second dose, he's gonna take 16.83 milligrams, and just before third dose he's gonna take 16.77 milligrams, 17.77 milligrams. And in section B, long run drugs amount before each dose is 17.83 milligrams. Now I'm gonna continue to the question 2. Okay, So here, first I gonna start by reading the question first. So a pendulum oscillates with a small angle displacement modeled by fx equals sine x. Billy wants to approximate sine x near x equal pi over 8 using a Taylor polynomial of degree 4. Now we look at the A. Write at the degree 4 Taylor polynomial P for x center at x equal pi over 8. So first, we know that fx is equal to sine x, and x is equal to pi over 8, and the degree is 4. So here, we know that the Taylor formula is p the degree of 4 x is equal to fx plus the fx derivative of fx times x minus a plus the second derivative of fx over 2 exponential times x minus 2 square plus f exponential x derivative 3 over 3 exponential times x minus a times the power of 3 plus f4 f derivative 4a over 4 exponential times x minus a power of 4. So here first we're gonna derivative all of the function. So fx is sine x and the second derivative is cos x, and cos x can be derivative to minus sine x, and minus sine x can be derivative to minus cos x, and for the fourth time is sine x. So here by input all the value to the formula, here's what we will get for the A section. Okay, let's continue. I'm sorry since I forgot to put my B and C work like in the PDF, so I'm gonna explain this part like in the picture. So here, gonna continue explaining. So here we know that absolute R degree for x is less and equal than m absolute x minus a power of 5 over exponent 5 exponential. So here we know that the m is equal to 1 and r is equal to 1 over 4. So by putting all this formula, we're gonna get 0.000008, and this is for the B section. And from the C section in the question, we know that find the interval around the pi power of pi over 8 where the approximation is accurate within 5 times 10 power of negative 6. So here we know that r the power of 5 over exponential 5 is less than 5 times 10 power negative 6. So here by putting all this form, and it will change to r the power of 5 over 120 is less than 5x 10 the power of 6. oh sorry, r the power of 5 is over 120 is less than 5 times 10 the power of minus 6. So here we will change the value, or we will form it. So r5 is equal to 6, since we move the 120 to to the other side, and we will it will form it 2 times, and we're gonna time it, and we will get this value 6 times 10 minus 4 the power of minus 4. And here r is less than, and we're gonna move the power from r to the other side, and here we will get r is less than root of 5 x root of 5 roots of 6 times 10 the power of minus 4, and this value is gonna be 0.190. And from here we gonna form it to pi over 8 minus 0 times minus 0.190 comma pi over 8 plus 0.190, and the value is gonna be 0.202 and 0.582. These two value is the interval around pi over 8. Okay, I think that's all about my explanation. Thank you so much for your attention.